Hello guys, we want to start chapter 29. In this chapter, I want to talk about the Fourier cosine series and Fourier sine series. So in the last lecture, we talked about the even function and odd functions, and we talked about properties of these two types of functions. So in this lecture, I want to find Fourier series of even function, and then I want to find Fourier series of odd function. For example, at first, imagine we have a function, so fx, and fx is the even function, is even. So as a result, we know that for even function, f minus x is equal to fx. And we talk about properties of even function in the last lecture as well. If I want to find Fourier series of this function based on definition, Fourier series is equal to a0 divided by 2 plus summation of an cosine n pi over px plus summation of bn sine n pi over px if fx is defined on the range of minus p to p. And a0 is equal to 1 over p minus p to p fx dx. An is equal to 1 over p, the integral from minus p to p fx cosine n pi over px dx, and bn is equal to 1 over p, the integral from minus p to p fx sine n pi over px dx. So let's find a0 for one even function. Imagine fx is even. So we know that based on the properties of even function, the integral from minus p to p is equal to, so here we have 1 over p. The integral from minus p to p fx dx for even function is equal to 2 times the integral from 0 to p fx dx. As a result, a0 is equal to 2 over p, the integral from 0 to p fx dx. Now let's find an. An, we have 1 over p, the integral from minus p to p fx cosine n pi over px. We know that fx is even function, and we know that cosine n pi over px is even function. Product of two even function is even function. As a result, I can say that this integral is equal to 2 over p, the integral from 0 to p fx cosine n pi over px dx. Now I want to find bn. So in bn, we have the 1 over p, the integral from minus p to p fx sine n pi over px dx. So we know that fx is even function, sine n pi over px is odd function, product of even and odd function is odd, and the integral of odd function on a symmetrical range is equal to 0. As a result, bn is equal to 0. So we could find a0, an, and bn. As a result, I can say that the Fourier series of an even function on the interval minus p and p, which is the cosine series, is like this. So fx is equal to a0 divided by 2 plus summation of an cosine n pi over px n from 1 to infinity, and a0 is equal to 2 over p, the integral from 0 to p fx dx, and an is equal to 2 over p, the integral from 0 to p fx cosine n pi over px dx. It's a cosine series or Fourier series of one even function. Now we want to find cosine series of odd functions or Fourier sine series. Imagine in this case fx is odd function. So in fact, fx is odd. It means that f minus x is equal to minus fx. If you want to find Fourier series, we have the same definition. So a0 divided by 2 plus summation of an cosine n pi over px plus summation of bn sine n pi over px. We have to find a0, an, and bn. So if I want to find a0, so we have 1 over p, the integral from minus b fx dx. Fx is odd function. Based on properties of odd function, the integral on a symmetrical range, so it's equal to 0. As a result, a0 is equal to 0. Now I have to find an, so we have 1 over p, the integral minus b to p fx cosine n pi over px dx. Fx is odd function, cosine is even function, product of even and odd function is odd function, and based on properties of odd function, this integral is equal to 0. Now we have to find bn, 1 over p minus p to the integral of minus b to p fx sine n pi over px. So fx is odd function, sine is odd function, product of two odd functions is even function, and based on properties of even function, so this integral is equal to 2 over p, the integral from 0 to p, fx sine n pi over px dx. As a result, the Fourier series of an odd function on the interval minus p and p, which is the sine series, can be written as follows. So for what odd function, we have Fourier series of fx is equal to summation of bn sine n pi over px, and from 1 to infinity, and bn is equal to 2 over p, the integral from 0 to p, fx sine n pi over px times dx. So it's Fourier series of odd function or sine series. So now we know cosine series, we know sine series. We want to solve one example. In this example, you want to find Fourier series of following functions. So we have fx is equal to 0 if x is between minus 1 to minus half, cosine 2 pi x if x is between minus half and half, and is equal to 0 if x is between half and 1. So at first we have to see this function is even or it's odd function. So if f minus x is equal to fx, we can say that the function is even. So fx is even. And if f minus x is equal to minus fx, function is odd. So if I take 1x from this range, from minus 1 to minus half, let's say a number between minus 1 and minus half, so it's minus 3 over 4. F minus 3 over 4 is equal to 0. Now I want to find f minus x, so minus 3 over 4. So in fact it's equal to f 3 over 4. So you can see that now we are in this range. So again the function is equal to 0. In fact, if you pick any number in this range, minus x between minus 1 and minus half, and you find f minus x, so you can see that both of them are equal to 0. And if I pick any x in this range, minus half to half, so I have cosine 2 pi x, and cosine 2 pi x is even function in all the ranges. As a result, we can say that fx in this function, f minus x always is equal to fx, so it means that fx is even function. So now we have fx as an even function, so we want to find Fourier series of even function, which is cosine series. So we know that for cosine series, fx is equal to a0 divided by 2 plus summation of bn cosine n pi over px, and n is from 1 to infinity. So at first we have to see what p is. So here, if you look at the function, you can see that the function is defined on the range of -1 to 1. As a result, in Fourier series, we said the function is defined in the range of -p to p. So we can see that p should be equal to 1. So now we back to definition of Fourier series. So we have p is equal to 1. Based on cosine series, we have a0 is equal to 2 over p, the integral of 0 to p, fx dx. It's equal to 2 over p is 1, 2 over 1, the integral from 0 to 1, fx dx. It's equal to 2 times. If you look at the function, so you can see that if x is between 0 to half, we have one equation, and from half to 1, function is equal to 0. As a result, I have to split the integral to two integrals. One is from 0 to half. fx 0 to half, fx is equal to cosine 2 pi x plus the integral from half to 1. So if x is between half and 1, so fx is equal to 0. So we have 0 dx is equal to, this guy is equal to 0. We have to find the integral of cosine 2 pi x dx. So a0 is equal to 2. Integral of cosine 2 pi x is 1 over 2 pi sine 2 pi x. X is between 0 to half. It's equal to 2 times 1 over 2 pi is 1 over pi. When I apply upper limit, so we have sine pi. When I apply lower limit, we have sine 0. So sine pi is equal to 0. Sine 0 is equal to 0. As a result, a0 is equal to 0. So now we have to find an. An based on definition of cosine series, so is equal to 2 over p integral 0 to p fx cosine n pi over px times dx. So it's equal to p is equal to 1, so we have 2 integral from 0 to 1 fx cosine n pi over p. P is 1, so it's n pi x dx. Again, I have to split the integral to two integrals. So we have, it's equal to 2 times integral from 0 to half cosine 2 pi x, which is the function, times cosine n pi x dx. So we have to find this integral. So we know that when we have cosine A, cosine B, so it's equal to half cosine A minus B, cosine A plus B, plus cosine A minus B. As a result, an is equal to, so we have 2 times half, so it's going to be 1. So we have 2, here we have half, so it's 1. the integral from 0 to half cosine a plus b. A is 2 pi x, b is n pi x, so it's gonna be 2 plus n pi x dx plus 2 times half, so the integral from 0 to half cosine a minus b, so it's gonna be 2 minus n times pi x dx. It's equal to 2 times half is 1, so an is equal to 1 over 2 plus n the integral of cosine 2 plus n is 1 over 2 plus n sine 2 plus n pi times x, so the limit of integral is from 0 to half plus the integral of 2 minus n cosine 2 minus n pi x, so it's 1 over 2 minus n times pi sine 2 minus n pi x. So the limit of integral is from 0 to half. And here I have to have 1 pi as well. It's equal to. So an it's equal to 1 over n plus 2 or 2 plus n, doesn't matter, pi. If I apply upper limit, so we have sine 2 plus n pi over 2 and here we have 1 over 2 minus n pi. If I apply lower upper limit, so we have sine 2 minus n times pi over 2, and if I apply lower limit, so it's equal to 0. So I could find an. We already found a0, which was equal to 0. As a result, we have the Fourier series. But there is one point here. If you look at here in denominator of this part, so you can see that n cannot be equal to 2. In fact, your Fourier series is valid for n greater than 2. So it's for valid for n3, 4, 5, and so on. As a result, we have to find Fourier series for n equal to 1 and n equal to 2 individually. And after that, we can use an for n greater than or greater than 2. So as a result, I have to find a1 and I have to find a2. If I want to find a1 based on definition, so a1, so based on definition, we had 2 over p, the integral from 0 to p, fx, cosine n pi over px, n is equal to 1, so we have pi over px dx. So it's equal to p is 1, so we have 2, the integral from 0 to 1, fx cosine pi over px, it's equal to, so 2 times the integral from 0 to 1, so we know that if you look at the function is equal to 0 when x is between 0 to half, between half and 1. As a result, it's equal to the integral from 0 to half cosine 2 pi x cosine pi over p. Pi is pi and p is 1, so we have cosine x pi x dx. So it's equal to, if I just use the equation for cosine A, cosine B, so we have integral from 0 to half cosine A plus B, so it's going to be 3 pi x plus cosine A minus B, so it's going to be pi x dx. So it's equal to 1 over 3 pi sine 3 pi x 0 to half plus 1 over pi sine pi x 0 to half. It's equal to so if I apply upper limit, so here I have 1 over 3 pi sine 3 pi over 2, sine 3 pi over 2 is minus 1 plus 1 over pi. Here if I apply upper limit, so you have sine pi over 2 is 1, lower limit is sine 0, so it's 1. So as a result, it's equal to 2, so it's going to be 3 pi. Here we have minus 1, here we have 3, so it's going to be 2 over 3 pi. So A1 is 2 over 3 pi. Now I have to find A2. So A2 is equal to 2 over p, the integral from 0 to p fx cosine n pi over px dx. So we have the same scenario, p is equal to 1, so we have 2 integral from 0 to 1, but we know that the function is equal to 0 when x is between half and 1. As a result, just consider the integral from 0 to half. Fx is cosine 2 pi x, and I want to find an when n is equal to 2. So as a result, here we have n equal to 2, so it's going to be cosine 2 pi over px dx. So it's equal to, so we have 2 cosine squared 2 pi x. As a result, I can use the equation that we already have. Cosine squared is half 1 plus cosine 2 times 2 pi x, so it's going to be 4 pi x dx. So it's equal to integral of 0 to half x, 1 plus cosine 4 pi x it's equal to x plus 1 over 4 pi sine 4 pi x. The limit of integral is 0 to half. So if we have halves, we have, I just plug it for x, it's going to be half plus sine 4 pi times half is going to be sine 2 pi. Sine 2 pi is equal to 0. If I apply lower limit, so x is equal to 0, sine is equal to 0. As a result, A2, we could find it as well. So now we have A1, we have A2, and for the rest, we already found AN. So we can say that the Fourier series of this function or cosine series is equal to A0 divided by 2 plus summation of AN cosine n pi over px, and from 1 to infinity. So in fact, fx is equal to A0, we already found it, is equal to 0. A1, we already found it. So A1 was equal to 2 over 3 pi. So we're going to have 2 over 3 pi cosine n is equal to 1. We have pi over p. P we know that is equal to 1. So it's going to be cosine pi x. Plus a2, we found it, a2 is here, it's half cosine n is 2, so it's going to be 2 pi times x. Let me 2 pi times x plus, and for the rest we have an, and from 3 to infinity cosine n pi over px. P is 1. N times pi times x. And we already found an. An is here. So we have an. You have to just plug it in this equation. So we could find cosine series of given function.